Well, good afternoon and welcome back to AIEC Webinar Weeks, bringing you not just products but also solutions. AIEC Webinar Weeks aims to address today's industry challenges and opportunities along with solutions and tips on how to overcome them. A couple housekeeping items here. Our presentation will last roughly 40-45 minutes. We'll leave 10-15 minutes at the end for some Q&A. Please submit your questions through the chat function. You can direct those to AIEC using the little drop-down box, and Brian and myself will moderate those questions to our presenter today. With that, I'll allow Brian to do our introductions.
All right, perfect. Today we have Mark Dre. He is the North Regional Sales Manager for McWane Poles. He's fairly new to the utility business, having started in July of 2019, but has extensive experience working with manufacturers of electrical products in other industries. McWane has been a manufacturer of iron products for 100 years, with the poles division beginning in 2008. So with that, I'll hand it up to you, Mark.
All right, thanks guys. Appreciate you guys giving me an opportunity to come in here today to talk about some alternatives to wood poles. So I'll jump right into it. All right, so again, I have my contact information if anybody wants to reach out to me afterwards. If you think of some questions later on, I'd be happy to get into contact with you to answer anything you might have. All right, so getting right into aging infrastructure. So, you know, wood poles have been around many years. Wood poles are still the primary material for our distribution and transmission networks. There are approximately 150 million poles in service, and about 6 million get changed out every year. And I mean, the truth is, these systems have been around a long time. Obviously, they see a lot of wear and tear, and and it just seems like with more recent storms, it just seems like storms get worse and worse all the time. If that has to do with some of the environmental changes and whatnot, but we're seeing more extreme summer and winter storms. As far as infrastructure hardening options, the NESC, that's basically where we go for some of the standards as far as the distribution and transmission systems. And these standards alone might not be the best for extreme weather situations. So again, every year we hear about storms knocking out systems and big parts of systems and putting down utilities for a while. And just this past summer, we heard about those derecho storms that went through Iowa, and I believe it hit part of Illinois as well. And I know it took some time for them to rebuild some of those networks over there in Iowa. And a lot of it's related to just these aging wood poles, and they just don't stand up to some of those storms. So, I guess the common practice for, upgrading poles is to look at stronger materials than wood. So, you have the option for metal poles, concrete, or even composite poles as an option. And of course, those materials also come at a premium to wood. With wood, you always got that, that first cost, benefits, the lowest cost option, but it's also the option that's, probably not going to last as long. It's going to require more maintenance. So why is system or line hardening important? I guess I'll show some photos in the next few slides of some windstorms and some damage. Snow and ice. Obviously, the ice on the lines and can potentially take down poles. High wind storms, again, those derecho storms and just tornadoes can take down poles. And of course, with wood poles, a lot of times you got that cascading effect when you got one pole go down, and then all of a sudden you have multiple poles go down. Again, talk about showing the cascading failures of some of these wood poles. You know, and a lot of times these storms will really test to really see how strong your system is. You know, you may think that you're doing your, you know, your inspections and your wood poles are strong, but you know, a good strong storm will come through and really put that system to the test, and many times take down the wood poles. And of course, poles nowadays are designed to hold not only electrical but also phone and cable TV as well as internet services. And when they go down, you know, you're taking down a lot of the other services with it, making for a lot of upset customers. And of course, with wood poles go down, you know, when you're out, you know, when these are out of service, you know, and yeah, you have some, it's expensive. You know, at times if they're more than what your teams can handle, then you got to bring in teams from neighboring counties or states to help you to rebuild and put the system back together. Again, you know, wood poles, I mean, even though I mentioned some of those non-wood options, I mean, we're never going to replace the, you know, wood poles entirely. You know, we can do is kind of, you know, chip away at it, you know, and sell these poles in certain applications. And but with wood, you know, you got you know, they're more susceptible to ground rot and fungus and woodpeckers, as are shown in the pictures here. And of course, with wood poles, you have to do you know, more inspections and more frequent inspections. And then sometimes, you know, you might put some, you know, Band-Aids on it, you know, just to make these poles last longer. But ultimately, you know, they do need to be replaced by either another wood pole or a wood pole alternative. So some of the alternatives, you know, you got your concrete poles, which aren't too common around in the Midwest. We see more of those kind of Florida. You see a lot of concrete poles. Texas, I believe, has quite a few concrete poles. Steel, which I'm sure you guys use around here. Fiberglass or composite poles. You know, I've seen some of those in Illinois and Wisconsin, and I'm starting to hear more and more about composites. But I'm going to focus on ductile iron, since that's what I'm most familiar with. So kind of from here on out, I'm going to focus more on ductile iron as a non-wood pole alternative. All right, so I know you want to ask me, hey, Mark, what's ductile iron? So cast iron or gray iron's been around for hundreds of years, and it's a product that's well known for its durability and also resistant to corrosiveness. So ductile iron was developed shortly after World War II. I think it was 1947 when it came about. And what they did was they introduced a magnesium treatment into the process of casting or molding the iron. And what that did was, if you look at under gray iron and ductile iron under a microscope, gray iron, the material is made up like of a lot of small flakes, and that's why it's so brittle, such a brittle product. It's very robust, you know, very durable. It's just it's brittle. Ductile iron, what that magnesium did was it decreased the tensile strength of the product. So it made the product so it can bend without breaking. So as you look under the ductile iron under a microscope, instead of seeing the flakes, you'll see these round little nodules. So after ductile iron was developed, so McWane has been around for 100 years, and this, you know, big year for McWane. It's our 100-year anniversary of being a company, and McWane is you know, a sizable company in that we have 25 companies that make up McWane. We're in a lot of different businesses, but we're primarily known for our iron products. We make iron pipe and iron fittings and couplings and valves and fire suppression equipment and whatnot. And so when ductile iron became developed, we actually were one of the early integrators to take it on and put it in our factories. And so in the 50s, we swapped over a lot of our plants from the gray cast iron to the ductile iron process. So we've been working with it for a long time. So some of the common uses for ductile iron, you got, manhole cover there. You got some of the hardware that's actually mounted onto utility poles. And we got some automotive equipment like brake pads there, and it's made out of ductile iron. We got water pipe, as I mentioned. That's a big part of McWane's business, is we make a lot of ductile iron water pipe, and then ductile iron fire hydrant. So again, iron, very robust. It's going to last a long time. It's just the drawback to the cast iron. It's brittle, where ductile iron is a little more flexible. So benefits of ductile iron. So again, it's a corrosion resistance. So we did a salt fog test comparing ductile iron to Corten or weathering steel, and the both pieces of material were exposed to the salt fog for a period of 5 weeks. And as you can see, the Corten steel, it bubbled up and flaked off, whereas the ductile iron, it'll oxidize and it'll change color. So just like with our poles, when we ship our poles out of the plant, they'll be kind of a grayish color. Then over about a period of time of about a year to 18 months, they'll oxidize and turn more kind of a rusty color. So the results of the salt fog test were that the steel lost 50% more material than the ductile iron over that period of time. So under same conditions, ductile iron could potentially last twice as long as steel. Fire performance testing. I'm sure you guys are aware or have heard of some of the issues out on the left coast with forest fires. A couple of the big California utilities with their issues with forest fires, and there are lawsuits involved with that. And they actually had some testing done. They partnered with a company out there to do some fire performance testing, and they invited basically all of the alternative players in poles. And so we sent a pole out there, and they did concrete, they did steel, they did composite, and I guess in the end, ductile iron performed the best out of all the materials tested. And if we have time at the very end, I do have a video showing the ductile iron poles being made. And again, these are molded in 2,600 degrees Fahrenheit. So yeah, they can withstand quite a bit of heat. And also, I'll comment too that one of those big California utilities is planning on using our poles in those high-risk wildfire areas. Conductivity testing. We hear all the time about copper theft, and that's it's an ongoing problem. We had one of our poles sent to AEP, and I believe that was a 45-foot class 1, and we just wanted to have them do a conductivity test, and the results were that it was basically the equivalent. It tested to the equivalent resistance of a 4-aught copper ground. So if in the event, we still recommend that you ground the ductile iron pole as you would with a wood pole, because our ductile iron poles are considered wood pole equivalent. So however you guys ground those today, we recommend you continue that practice. But in the instance if the grounding or the copper is stolen, you still have that I guess assuredness that the pole is still conductive. All right, resistant to Mother Nature. Wood poles, you got certain areas, woodpeckers are always a threat, and picture on the right, with ground rot, with ductile iron, these issues will be a problem. Sustainability. you know, a lot of times those wood poles are treated where, you know, you can't really recycle them. They, you know, they become many times they're scrap. Our ductile iron poles are made with 95% recycled material, and they're 100% recyclable at the end of their lifespan. And then we also put on a ceramic epoxy embedment coating. We coat the inside as well as the outside of the pole, and our standard is that we put it 1 foot above ground line. Of course, you can adjust that if need be, if you're in a, you know, a bog area or something like that, and you want to go up, you know, 2, 3, 4 feet. Of course, we can apply more of that coating. And then with wood poles, you know, some of those treatments, you know, you can't be in an area where it has, you know, it's potable, where you have potable water, because those wood treatments will contaminate. Our ductile iron poles have been approved to be used in potable water locations. Load testing. So here's kind of a diagram of some tests we had down here a few years ago. And this was a 50-foot class one that we tested. And the diagram there shows how we, at the base, we fixed the pole, and then at the top we put a strap 2 inches from the tip where we applied load. So I'll get in here to the next slide showing some photos of the actual test. So again, base is fixed, strap was attached 2 feet from the tip, and then we apply load. So 2.95 kips or 43 inches deflection. So this is where most wood poles are rated at, and this is where most of them at this point, or just beyond this point, they'll fail. So we tested to this point and then released it. And then we tested at 130% of class load, 3.84 kips and 58 inches of deflection. Again, no breakage. We released it back. And it wasn't until 173% of class load, or 103 inches of deflection, before that pole failed. And I wasn't there for the test. I wasn't around at that time, but I asked, I said, hey, you know, how does a ductile iron pole fail? You know, does it splinter? Is it, you know, so what was described to me is that like if, I guess he described it like if you have a raw carrot, I mean, you snap it. So you know, it's a clean break when ductile iron does fail. So it was a clean break right near, I guess, where the ground line was. And again, 173% of class load. We tested 5 different classes and heights of poles. And if anybody's interested, I can, you know, more if you want to reach out to me, I'm more than willing to send you those test results, just so you get an idea of, again, the tensile strength and flexibility of ductile iron compared to other products or wood, you know, showing again, being a wood pole equivalent, how much stronger ductile iron is by comparison. So here's kind of the chart showing, again, the test results and how superior it is compared to where a wood pole could potentially fail. Product support areas. So we provide poles for distribution and transmission applications, and got some pretty photos there. Distribution applications. So that first photo there, that's for a pole down in Alabama, and that's a critical and assets pole. You know, there's obviously a lot of work went into assembling all that equipment on that pole. And this particular utility decided that for those type of applications, when there's that much labor involved to change out all that equipment, they did not want to do that. You have to do that again in, you know, 20, 25 years, or whenever that wood pole would fail. And you know, the lifespan of ductile iron, you know, we're saying 75 to 100 years. And so for them, it made sense to, you know, pay the premium for the ductile iron for these type of applications. The middle photo there is a storm hardening that they did down in Oklahoma, and I'll get into that later. But basically what they did was they installed ductile iron poles in conjunction with wood poles to storm harden their network. And then the third photo there is a photo down from the Florida Keys. They replaced a lot of concrete poles with ductile iron, and they had us paint them gray because they had so many concrete poles. They wanted to kind of match some of the concrete poles that they had. So again, there's another kind of success story I'll talk about later on in the presentation as it relates to Florida Keys. Transmission applications. So we got Idaho there. We got 115 kV line. So here's an application where wildfire went through, wiped out a bunch of wood poles. And so these guys decided they weren't going to mess around with wood poles again, and they went in and put in all ductile iron for that application. Middle photo there, near Las Vegas, they have an unguide 80-foot 8.6 pole with 69 and 13 kV. And then that third photo there on the right, that's with Central Power. They're a part of the Touchstone network. They're up there in Minot, North Dakota, and they had an area where it was a wetlands area, and access was not very easy, and they didn't want to disturb it. So for them, it made a lot of sense to replace those H-frames, and they went with ductile iron for that whole run of line through there. And again, with their thoughts were with the ductile iron, a lot less maintenance, a lot less inspections, so they wouldn't have to go into that wetlands area. In the field, so we ship out ductile iron poles out. If they're 70 foot or less, we'll ship them out in one piece. Just from our user experience with shipping these poles, that's kind of the max length. If you get beyond that, then you have to have special permitting, and then the freight cost goes up quite a bit. So we recommend that any poles that are 75 foot or taller to be shipped in two pieces. And the photos there shows the guys in the field jacking the two sections together. Installation. It's much like the wood poles that many of your crews install today. Very similar equipment. Not much difference. I guess the only thing that comes to mind is instead of having a chain when you're kind of hoisting up or lifting up these poles, we recommend maybe a nylon sling, just so you don't scratch up and scuff up the pole as much. But very equipment, very, very similar to equipment used today. And actually, ductile iron poles, by comparison, are lighter than the wood poles by 25–30%, depending on the class and the height of the pole. So why ductile iron? So with ductile iron, it's with our poles, it's an engineered product. You're going to get that structural and dimensional consistency every time. And as I mentioned earlier with the test results, it's much stronger than wood. With ductile iron, you won't have to go back. Your crews won't have to go back and retighten the hardware over time like you do with wood. And then we've got our pole library available in PLS and some of the other platforms, SPIDA and Ocalc, I believe, as well. Life cycle costs. So that's one of the things that some of the co-ops look at when they evaluate, is ductile iron good for that application? And they'll look at, hey, maintenance costs and the life of wood poles versus, ductile iron. So again, ductile iron is a superior product in these, corrosive environments. And, a lot of these pilot projects we see are in wetlands areas. And, as I mentioned earlier, their ductile iron is impervious to rot, insects, and woodpeckers. Expected service life, we've only been around since 2008 as far as making ductile iron poles, but we estimated the lifespan to be anywhere from 75 to 100 years. And that's just based on our experience with some of the other products we make with the iron pipe and some of the other iron valves and products. And it could be longer. We just, we thought that was just a good, from a marketing standpoint, a good number. And typically that's going to be 2-3 times as long as many wood poles. And as I mentioned earlier, they are 100% recyclable. So, none of us are going to be around when these poles ultimately fail. But they give us a call. We'll come pick it up and make them into new poles. And again, that cash value, you can sell the metal for scrap, and when these poles are taken out of service. Lineman friendly, as I mentioned earlier, it's a lot of the same equipment that your crews use today. A lot of the same hardware. As far as field drilling, I mean, we would prefer to in the factory drill the holes for you guys, or at least the lion's share of them, so you guys don't have to worry about it. And we do that for most customers. They'll send us their drilling specs. When we manufacture them, we'll drill them out to those specs. But of course, there's always that occasion where hey, or the hole was missed, or hey, we had to have something here where we need to mount on it. We didn't think about it initially. And so ductile iron, if you use some of the bits we recommend, you should be able to drill it out in about 30 seconds to a minute. As I mentioned earlier, ductile iron is lighter than wood by about 25 to 30%, 40%. We are heavier than steel by comparison, and we're probably 15 to 25% heavier than steel, and that has to do with wall thickness. Our ductile iron, our wall thickness is thicker compared to the steel. And again, our poles are self-grounded. You would not have to ground them, but again, as I mentioned earlier, I would recommend that you ground them as you guys would today with your wood poles. All right, success stories. So mentioned earlier, Florida Keys. Some of you recall 2017 Hurricane Irma. I guess the Keys, has been largely protected, it seems like, for hurricanes for years. They seem to always dodge these hurricanes, but we finally caught up with them. And in 2017, Irma came through and wiped out quite a few wood and concrete poles. And prior to that, Florida Keys had already started to use some of our ductile iron poles as they replaced, some wood and concrete poles, and their crews loved them, and they just liked the fact, at least compared it to concrete, how much lighter they were, how much easier they were to install. And so if you guys want to take a field trip, I recommend Florida Keys. You'll see a lot of our ductile iron poles down in the area. Chimera Electrical Co-op down in Oklahoma. They've had some problems with ice storms over the years. 2002, they lost 16,000 wood poles. And then 2013, they had another ice storm that wiped out a bunch of wood poles. And then they worked with a consulting engineer to come up with a way to strengthen their system. And what he did, he recommended basically using ductile iron poles in conjunction with wood poles. So they had basically 4 ductile iron poles per mile mixed in with the wood poles. And when at the time they were building, this line, another ice storm came through, and I think that was 2015. And again, it knocked out a lot of their wood poles, but the section that they had already started working on with the storm hardening project, they didn't lose a single pole. So they've been, very satisfied with the end result of their storm hardening initiative using the ductile iron in conjunction with the wood poles. Application photos, just some different photos around the country with some of the heights and classes we offer. So 55-foot H1 and 45-foot class 3. Got a riser pole there in Nebraska, equipment pole there in Tennessee. Got a 40-foot class 3 there in Iowa. 65-foot class 1s along that road there in York, Nebraska. Got a 50-foot H1 there, substation in Tennessee. Some 70-foot class 3 communication tower there in Nebraska. And we got some some poles there in San Angelo, Texas, as well as, the coated poles in the Keys. And again, the reason they coated them, I guess two reasons. The coating, being more of a saltwater type environment, they were concerned that saltwater air might, shorten the lifespan of the pole. Plus they, wanted to look like the concrete pole, so they coated. So yeah, they probably added life, most likely added life to that pole by coating it. And then 75-foot H1 there in Indiana, upgrading from a wood pole. And then Las Vegas, we got a nice coated pole there right along the Las Vegas Strip. I believe that is right across the street from New York Casino. And then, so I guess that brings me to kind of the end of my presentation. So it looks like I have time, so I'm going to jump ahead one slide here. I got this little video that we have here, shows kind of our poles being made, and then I can back up to, if we have questions here. So this is our plant in Provo, Utah. So again, I guess a quick thing about McWane. So the poles division, we have two locations. We got a plant in Coshocton, Ohio, which is about 70 miles kind of northeast of Columbus. And then we have Provo, Utah, which is about 45 minutes south of Salt Lake. So we got two plants there. And we actually, both plants actually produce pipe as well, water pipe, which is the foundry side of the business. And then the poles plants across the street, where we then assemble the sections into utility poles. So I will go ahead, and this goes pretty quick. So just to give you an idea how these are made. All scrap metal. Our pole sections are centrifugally casted, and that molten iron is probably about 2,600 degrees Fahrenheit. We make the pole sections. They're basically 18-foot sections, and then we'll cut the flange end off. And typically we have about 15 feet is when we start building them into poles. Cutting off the flange section there. So now they're at the pole side of the business. Checking different tensile strength and different tests we do out of each lot that we mold, just to make sure that they meet our specs. we'll press the sections together using a 50-ton press, and then we'll pin it. Drilling out the holes per customer specifications. Actually, this process has improved. This video is a couple years old. It's more automated today. Spot welding on base plate. Applying the embed coating, again, inside and outside the pool. Stack them on the wood dunnage for shipping. All right, I'll stop there. Any questions from anybody?
Mark, I gotta tell you, I'm a sucker for that show. How is it made? So I appreciate that. That was a very interesting video. Although I am kind of curious what the temperature of that shop is in July.
Oh gosh, yeah. Try not to do too many tours that time of year because we'll probably have people pass out.
Yeah.
We have gotten a couple questions. Do you need special equipment for installation of ductile iron poles?
No. Typically, what you know, your crews are using today to install wood poles is all they really need. Like I said, you know, instead of using a chain when you kind of hoist up these poles, you know, we recommend maybe a nylon sling so you won't scratch up the poles as much. And then the only other thing is, you know, we have some recommended bits, drilling bits, in case you guys do need to drill out in the field. We got some Milwaukee and I can't think of the other manufacturer name, but drill bits, Unitech drill bits, steel carbide drill bits that we recommend that are best for drilling the ductile iron. But other than that, no, it should be, I mean, just like you would wood poles.
All right, one last question, which I think you kind of touched on already. How do the ductile iron poles compare in weight to wood, concrete, or steel?
As far as like from a weight standpoint?
How do they compare in weight?
So we're, you know, depending on the height and the class, you know, the ductile iron compared to wood, we're going to be lighter, you know, because we're hollow, and you know, we could be substantially less than when you're getting into some of these big, you know, H-type poles, you know, let's say it's an H5, H6, you know, we're going to be substantially less weight. And compared to steel, we're going to be a little bit heavier, 15, 25%, just because our wall's thicker than the steel pole. And then concrete, yeah, we're definitely much lighter than concrete poles. That's why the folks in Florida decided to, you know, go away from concrete and do more ductile iron just from a weight standpoint and ease of installation standpoint.
Well, Mark, I think that's all the questions we have. We want to thank you for your time. It's very informative, very good presentation. You've got your contact information up on the slide here. I would just encourage any of our viewers today to jot that down. If you have any questions for Mark, I'm sure he'd be happy to answer those for you. You can always direct those to us, and we can reach out to Mark as well. So again, thank you, Mark. We appreciate your time today.
Yep, thanks, guys. And again, we appreciate the Touchstone Network. Actually, they came up here a couple weeks ago. We talked about how important they are to our business, and we actually do a lot of business. A very large percentage of our business is with the Touchstone Network. So just want to thank you guys for using ductile iron poles, and yeah, consider us for these type of applications, especially, you know, like wetlands areas or high wood pressure areas, or, you know, or for storm hardening, as I talked about. Yeah, ductile iron is a great product for those type of applications.
Very good. Well, thank you very much. And just a quick reminder to our viewers today, if you missed any of our previous webinar episodes, you can go out to aiec.coop/webinar weeks, and we have an archive out there that you can view any one of our past episodes. This will be the last webinar for this week. We will start up next week, next Tuesday, the 26th, with another 4 webinar series. So we hope to see you then. Until next Tuesday, we hope you all enjoy the rest of your week. Thank you very much.